And one simple request is to keep things simple for the layman understanding.
Exactly, that is our problem. But try to, you ask me. I learned oceanography by sailing in the ocean or in the ocean, not like a textbook. I am basically a physics in atmospheric physics. So that's why if you are in the ocean, you get a curiosity of a lot of things, why it is happening and why not this is happening.
So if you look at your journey from a scientist to leading institutions and
Yes.
now Ministry of Earth Sciences,
Yes.
so how it changed your perspective towards research and science?
So when we are doing scientists, what we do is once you dive, that particular field will go on dive.
Yeah, right.
But if we never come back, what for we are diving, we forget it. We want to have more and more startup in our area.
Ministry of Earth Science often deliver value by preventing losses, then creating visible assets
Correct.
like space or atomic energy. So how do you quantify the impact?
Only for weather forecast and potential fishing forecast, what is the benefit? It is roughly about 37,000 crore per year.
I was just looking at those stations and I was like,
Yes.
wow.
So this is one of the best stations in Antarctica.
Antarctica. Bharati station.
Bharati station, and where we can live 100 people there at any point of time.
And indigenously built completely by us.
It is India.
Okay.
Of course, the design and other thing is important one. The Samudrayaan mission is two aspects. One is 3 human beings will go up to 6,000 meter dive. You know Gaganyaan.
Yeah, right.
The opposite of Gaganyaan is wherein 3 human beings will be in this what is called sphere, will be sitting and they will be going up to 6,000 meters.
6,000 meter.
Yes. We have to go because we need to understand the many things.
Yes, sir, I think we have explored space a bit, but talking about oceans, I think 96% of the oceans are unexplored.
See, space, how many people are working?
Many.
More than 10,000. Ocean, how many? And we have so much on the ocean. Ocean energy is the next domain we have to harness. So that definitely we need to develop various forms of technology for that. Similarly, why we cannot put a solar panel in the ocean? Why we have to put a land?
Now we will talk about Mission Mausam.
Yes.
So it focuses on, I think, improving weather forecasting and early warning system.
Finally, our dream is to make weather intervention, improvement of weather forecast, and we should not have a ChatGPT.
Okay.
Like that Mausam GPT.
What Delhi's pollution. So if we can talk about that, like from atmospheric perspective, like
Yes.
what are the reasons for Delhi's pollution, or it's just humans or us?
See, the Delhi pollution is unique because of one thing is Delhi is bounded with what is called, it is like a bowl. So any pollution we create, it is not dispersing out.
And sir, why globally Antarctica is so important, and that we talk about Antarctic Treaty, so it prioritizes science over resource extraction.
Correct.
So if we, like, as India expands its Arctic presence, so how do you balance scientific collaboration and geopolitical competition and these things?
See, unlike other places, in Antarctica is no man's land.
No man's land, okay.
No man's land. And Antarctica, the currency is science.
Hello everyone, welcome back to another episode of Chill Mizaj, and today we have Dr. Ravichandran ji with us. He is one of the most renowned scientists of India in the field of atmospheric physics and ocean technology, and currently serving as Secretary to Ministry of Earth Sciences, Government of India. Swagat hai sir, glad to sit in front of you.
Yes.
So before deep diving into oceans, Ministry of Earth Science, its projects, I would love to know about your journey and your early inclination towards science and particularly physics.
Yeah, of course, I started my career in physics in the, basically it is opportunity, whatever they available. I tried for engineering, I couldn't get, so I went to physics. It is not that I want to physics, frankly speaking.
Okay.
Then after my PhD and MSc, then I entered into do research in atmospheric physics. So I was doing on, basically my started in the lightning.
Okay.
To understand the characteristics of light. That is my PhD topic. I did my PhD on that. Then I worked in Indian Institute of Tropical Meteorology parallelly. Then after that, maybe about 8 to 9 years, then from the meteorology, of course, I developed an instrument to monitor the lightning, how the lightning segment wise how it is going, why it is propagating like this, why not like this. So I developed the instrument to monitor. So I become instrumentation engineer basically in that process.
Okay.
Then I made observation. Because my observation and instrumentation, then I moved to National Institute of Ocean Technology, wherein I have gone for marine meteorological instrumentation. So basically, it was housed in the NIOT, is in the IIT Madras.
Mm-hmm.
So their job is to observe the ocean. So I went for some training in Norway and other places. Then I become ocean observation man. It basically instrumentation, but the ocean observation, how to monitor weather and in the ocean. Then I was working about 4 5 years. Then instead of surface ocean, then people wanted me to go deep to ocean, up to 2 kilometers. So then that time I migrated from Chennai to Hyderabad. And I was working in Hyderabad, Indian National Center for Ocean Information Services. So I mainly worked on ocean observation up to 2 kilometers. Basically, they call Argo. That is an instrument name, basically. It is basically this will measure the ocean up to 2 kilometers every 5 days, every 10 days. Then afterwards, I worked in how to use that observation in motion model, then how to make a seasonal prediction of the ocean. Then I moved to, from the ocean, I moved as a director of National Center for Polar and Ocean Research.
Okay.
So then I was working on Antarctica, Arctic, Himalaya, and other things. Then later on, by 2021, I moved as a secretary here.
Sir, all the things that you have talked about are very fascinating. And as a child, we always used to get curious towards these things, but it is a very niche topic if we talk about research and study. So, how do you keep that curiosity alive and learning with time?
Yeah. So basically, it is a once I am lucky that I got the opportunity to go in this direction.
Okay.
But everywhere I go for new things, I always try to learn as much as possible. I might have sailed more than 500 days on board ship, research vessel,
500 days on a boat.
on a boat. So I learned oceanography by sailing in the ocean or in the ocean, not like a textbook. I am basically a physics in atmospheric physics. That is my topic. But how do I do? Most of my 20 years career, I worked in ocean, in the ocean. So that's why if you are in the ocean, you get a curiosity of a lot of things, why it is happening and why not this is happening. So all these things, and I have important thing is, I am fortunate to have all global leaders in oceanography to work with them, because I was working in a climate variability, some important global initiative. Knowingly, unknowingly, I was a member in that committee, but in that global leaders are there in the oceanography. So I was fortunate to sail along with him for more than a decade. That's why I could learn something, curiosity and all other things.
So, how is the experience of sailing on the boat? Like, I'm just curious to know that a bit.
We have a research vessels.
Okay.
So it is not a boat, it is a multiple things. It is not a small boat. I have sailed in small boat, in fishing vessel, a navy vessel, coast guard vessel, our own research vessels. Our own research vessels is like 100 meter. Okay. It is like a what is called cruise liner type. So it will be very happy. But it is a main objective is to understand the ocean and deploy some ocean instruments and other purpose. But once you go there, 30 days, you don't have anything. So you and ocean, nothing else. So that's why you get a lot of ignites or provoking some innovative questions and other things. So that motivates you.
So observation is a very long-term phenomena. So
Yes.
okay. So if you look at your journey from a scientist to leading institutions and now Ministry of Earth Sciences,
Yes.
so how it changed your perspective towards research and science, like creating impact on economy and nation's technology. So how it changed that perspective?
Yeah. So when we are doing scientists, what we do is once you dive, that particular field will go on dive.
Yeah, right.
But we never come back, what for we are diving, we forget it. We go on to deep research, but finally we forget why we are doing that research. But here, when I come here as a thing, now each one why we are doing research, and immediately it has to be applicability of society or technology. How can mankind utilize this? So
Right.
that is what the difference is. But here now I am sitting it now. Suppose government of India's vision is there. In 2047, you have to be like a Viksit Bharat.
Right.
So I look at it now as an administrator, how the ocean or meteorology or even polar science, this area, earth science per se, how we can contribute to the Viksit Bharat. That is the main objective. So if you talk about, assume that weather, we got so much improvement few decades, maybe in a decade, we have improvement in weather forecast, but we have to go much more because tropical weather is difficult when compared to other weather. I would always say that tropical weather is a vector quantity, whereas mid-latitude and polar region is a scalar quantity.
Okay.
So that's why this vector direction is matter. There the winds will be in one direction. Only magnitude will change. Here winds will go and also less. So it may go anywhere.
So it is difficult to predict in India.
So then we need to have that is why we need to have more and more observation, more and more understanding. If anything variabilities are more, it is easy to predict.
Right.
If variabilities are less, it is less to predict. So that's why our predictability is very less when compared to other places. So tropical weather is a complex. Or I would say that tropical weather is the typical auto. Here and there it will go. But whereas in the Europe and other thing, the weather is like a jet, like a train. If it comes here, next time
It will go in one
here.
direction.
That's it.
Okay.
So that's the main difference. But we need to have more and more observations, more and more understanding, so that we can improve. So our ultimate goal is in 2047. Now weather is managing us, whether we can manage weather.
Okay.
So we want to have a weather management. So what is that weather management? Means whether we can do intervention of weather, either for creative or destructive.
Right.
That is what that means. Then you should know better than what we know.
Right.
That means more understanding, more technology is required. Towards that, we are working on it. That's the weather.
Okay.
And the ocean perspective, we want to go for now blue economy. In the ocean, presently roughly about 4% of GDP is contributing to the.
It is more than $100 billion, I think.
Exactly.
Right.
So now how we can double our blue economy in terms of policy, in terms of technology, in terms of science, in terms of various services, how we can do.
Yes, sir. Exactly. Like if you look at India, like we have oceans three sides of the country.
Exactly.
And such a high coastal region. And
Interestingly, we are the only ocean where unique is we have one bay
right.
in Bay of Bengal, we have one sea, Arabian Sea, we have one ocean.
And we have an Himalaya too.
And interestingly, this is the only ocean named after India. No other ocean
Yeah, right.
named after any country. There is no other ocean. So we need to justify ourselves. And we need to harness the resources. At the same time, we have to have a sustainability in place. And we are looking at it various opportunity. See, if you talk about anything in the future, people were looking at food, water, energy.
Right.
These are the
Basic needs.
basic needs. And also we need to worry about health.
Right.
Okay, many new diseases will come, so we need to find out the various medicines and other things. So I personally look at it: food, water, energy, health. These are the four. Under these four will change as the time goes, especially in the global warming scenario. When the climate change is taking place, more and more warming world is coming, then these four, how it will modify,
Okay.
how food security will change.
So how we are going to adapt to the changing planet?
Exactly. So that's why we are looking at from the ocean. Food means how we can increase the protein from the fish or seaweed or many other things. How do we do? Water. How do we do desalination? Various technology. Similarly, energy. Ocean having plenty of energy. You name it, ocean thermal energy, tide energy, wave energy, wind energy, offshore wind energy. Why we cannot put solar panel in the ocean, floating solar panel?
Oh, that's a great idea.
Yeah, so many are there. So much energy is available. In the ocean energy, if you harness 1% of ocean energy within available in our coastal states, if you harness, India is more than enough, sufficient. So what is that blocking now?
Yeah, exactly. I was going to ask that.
Exactly. So there is some technology hurdles, some it is economical feasibility. Now technology is almost available.
Okay.
Now the present technology is not economically viable presently. So now we need to develop a technology for economically feasible. That's the main thing, our goal. So we are trying various options. I am sure in 2047 there will be a computer sitting in seabed, quantum computer. It will be giving weather forecast sitting in the seabed.
Okay.
Now you need a quantum computer. That means your models should be in quantum computer models. Then energy required deep sea. Why in deep sea? Because the energy required for in future, at least 25% of the country's energy is required for only computer storage,
Yeah, right.
data by this purpose. That energy, very difficult to produce from not producing. It is only heat dissipation. If you put it in the seabed, heat dissipation has become very easy. It is a cool water
Yeah,
as
right.
soon as you go down. So, but you require energy there to operate the compute. You produce from the energy from the ocean thermal energy. Now, if I put to ocean thermal energy in the deep ocean, my economic cost is coming to this land. I have to put a cable. That is
Right.
costly. If I use the energy there itself, it is cheaper. So that is why we are developing now various energy. So like that, various things we are looking at it, how we can contribute in terms of blue economy, or whether make what is called management, or we want to have a early earthquake warning.
Right.
And similarly, we want to be a global leader in polar science. It is a diplomatic and geostrategically important.
Right.
What is that we have to do? So all this angle we are looking at it.
You have talked about many things, Viksit Bharat, and the technologies that we are developing. So, talking about the roles of government and people. So, first about government. So, I think government particularly is focusing more on research part, and it is also privatizing many things in space sector, atomic
Yes.
sector now.
Yes.
So, now looking from the perspective of Ministry of Earth Sciences and role of people, like there are few people in academia, there are few industries, there are few
Yes.
MSMEs. So, how can we integrate them towards a common goal of Viksit Bharat?
Yes, I think that is very important, because that's what I'm telling. We cannot do in isolation. Even our own ministry cannot do.
So I think the role of the government is like a catalyst. So it
Correct.
can only
Exactly. Actually, we need to work with academia where the knowledge will come. We need to partner with the industry where they have to drive the service and technology. Because when we do, we are not having that much urge to deliver the product. If private industries are there, then it is important the value of various services or products has to be immediately used by them. If the research is what you are doing, if it is not useful for industry or anything, then where is the question?
Right.
That is where this trio has to be there. Now, how we have to catalyze, that's what we are working on it. Now we are planning to have more and more collaboration with academia, and with academia we are more strengthened now, but we need to go for beyond industry. So we are looking at it various industries. Suppose how energy, suppose you are producing renewable energy. So we are trying to help how you can do renewable energy in terms of solar and wind energy. So I give a forecast
okay.
for them. So then they can have an energy forecast. Accordingly, they will be able to do which energy to use tomorrow. Whether you have to use hydroelectric or renewable, depending upon the weather availability. Similarly, for various ocean people, services, if you are fisherman, if you go on ocean, where you have to go and catch the fish.
Sir, I was reading one of the articles, I think in the report of Ministry of Earth Science, there is a technology, I don't know whether it's Israel or which country, so they do fishing with the help of light, particular light kind of thing.
Yes. So basically what happened, you have to, nowadays there is a technology, instead of you go and fish,
Right.
you call the fish to me and catch.
And particular type of fish.
Yes. Even everything.
Huh.
So now we have started with fisheries. We used to give earlier fishing, potential fishing services,
Okay.
potential fishing zone, where you will get likely to have a fish. And people got it, but they are not happy. They want a species-specific forecast.
Okay.
Because where you are giving biomass, we are getting biomass, but that is not economically viable. We want only tuna, or we want only mackerel.
Okay.
So they were asking. Then that is a demand. Then we have to work for it. So what we are doing is, suppose tuna. We want to understand how the tuna is going. So we try to find out its characteristics. Tuna is a particular thing where it will only visual predator. That means it will see the fish and catch. It cannot swallow without closing eyes. That means the clarity of the water should be good, number one. Then we looked at other characteristics. It looks warm water, not cold water. And third thing is it will go as a school. That means as a group only it will go. Isolation it will not go. So now what we have done is we have big fish of tuna 5 kilo we catch and put a tag. Inside the tag we put various sensors and also GPS. Now where it is going, where it is living, we are monitoring along with the group of fish.
Right.
So now we look at the satellite where the clarity is good, where the chlorophyll is available, where the temperature is warm. All these things we are monitoring, and where the fish also aggregating we are seeing. Based on that, we are now able to give the forecast of potential fishing zone of tuna. Similarly, now gilsa we are doing. So we are trying to do various things.
Right.
That is what we are doing. Light, what you have mentioned is, it is also one of the aggregation device. Suppose you put underwater light, and that light cave, all the fish will come. So that then you catch it. And also we are doing FAD, that is a fish aggregation device. So now you catch fish in a closed area so that it will grow in the natural environment, but it will be available to you all the time. So these are all various techniques they adopt. So we are trying to do that also.
And sir, particularly talking about startups, like there are many startups who want to work with the government or in this field. So how do you align them with national interest?
Yeah, that's what, see, certain things we...
And one more thing is ki, talking about particularly this kind of startups and deep tech startups.
Yes.
So private funding is not very available in the starting days. So
No, we are looking at that avenue. Now we are basically, we want to have more and more startup in our area. Because our young talented groups are innovators. There are many available. Even for ocean observation also many people are coming with the drone. Ocean undergoing AUV and drone together. Like that, they are making.
so there is no bottleneck of talent. So talent is available.
Yes. Now how to source for their, how do we feed them in terms of, so we are having opportunity. Now very soon we are going to write up in our website, these are the challenging questions
Okay.
we are going to write. Anybody can come forward and try to solve that, which we are going to make it very soon. So suppose top 20 priorities, challenging questions. We are going to put it now very soon in a month or two, so that any innovators, industries, students, or anybody can come and participate. Then we will cater their need, whatever required.
Okay. So it is one of the most well-maintained websites I've ever seen. So most of the information I got from there only.
Okay. And we are trying to improve our the thing, because ultimately we need to communicate to the people.
Right.
Basically, most of the time we are passing the information, but whether it is reaching the what is called opposite people, we are not bothered. As if I am tweeted the message, I feel that I have communicated, but actually I have informed. I have not communicated. Communicated means how he respond depending upon my information. That is what communication. So we are trying to communicate with people.
Yes, sir, exactly. So that's why we need conversations like
Yes.
this. I think many people.
I think this is very useful. This is what we are lagging also still.
Okay.
We are not able to communicate with our users. We are not able to communicate with the industries. We are not able to communicate with maybe academia. Yes, partly is fine, but still we need to communicate. What we want, we have to tell. What people need, that we are the sandwich as we make, but we have to catalyst.
So I think At that place, we can make some difference.
Yeah, definitely. I think if you are able to communicate, this is our need, and we are like a catalyst. We want to go in a much bigger way. For that, we need to pull the resources from various kinds. And also, we are the only ministry. It is not only we want to resource from India, but also globally.
Right.
Okay, ocean is one ocean, global ocean. Atmosphere also one atmosphere. So we want to have a. Earlier we used to go and work for other country. Now I want to
Okay.
bring other people to come to work in my country for my problem, not to work other problem. So that is why we are also planning to have invite students.
So even I saw on the website too, like we are having many joint collaborations
Yes.
globally, and
Yes.
so how that works, what are the countries we are working with, and what are our plans with them?
So various countries we are working.
Okay.
For example, if you see that one of our problem is next season how the weather will be, seasonal prediction of weather.
Okay.
We are trying our level best. We couldn't do. Then we made open up seasonal prediction. This is our skill. We want to improve the skill from this to this. If anybody wants to come globally, please come and submit the proposal. Okay. They submitted the proposal globally. US, UK, and also Australia, all these people, they come. Only we have given the request, when you take a student, you take from India,
Okay.
so that they will be the future of our science. Like that, we made 5 years. That has revolutionized. And now we are able to give seasonal prediction of weather forecast in much better accuracy and also spatial variability, everything we are able to give. So it is not only foreign mind, but also we are working together
Okay.
with the global minds.
And sir, talking about India's role in the collaboration, so how India has evolved with times of before it used to be about ocean development, I think.
Yes.
Then it diverged, and
Yeah.
then you have many things under your
Correct.
same umbrella. So first question is like India's role,
Yes.
and second thing is ki like there are so many diverse things. So how do you
Correct.
keep them under one umbrella?
No, basically, initially it was working in silos. Ocean development separately, and atmosphere is separately, and then what is called earthquake and other things separately.
Right.
Now, there is a strong symbiotic relation between ocean and atmosphere. Suppose you want to predict tomorrow's weather, you have to depend on atmosphere.
Right.
If you want to go next 5 days, depends on atmosphere. But if you want to go for next season or next year or in climate scale, the memory is available in the ocean. So without oceans, you cannot predict next 10 days weather or beyond 10 days. So we have to have ocean and atmosphere coupled model is required to have a better forecast. That is why these two departments are joined together. Then similarly, all the earthquake and polar science, because whatever is happening today in polar, it will impact our weather.
Okay.
So how long it is taking time? Whenever there is a extreme rainfall is happening here, there will be a lot of heat transported in the atmosphere. That heat goes to Arctic. Then Arctic ice melts. Then once Arctic ice melts,
Water level rises.
water sea level will rise in the long term. But in the short term itself, there will be a lot of extreme rain happen here.
Okay.
That means Arctic ice melts, more extreme weather. More extreme weather means more heat transported from tropics to again poles. Again, it is a feedback. So that is we are worried.
And sir, climate change and rising sea levels are irreversible, right?
Of course, many things are irreversible. See, as of now, climate, whatever the Paris Agreement and other things, it is all gone beyond that. So now certain things, it is irreversible, but it is not, it is irreversible, so we cannot do any action. No, it is not correct. So we need to do something for how to make the reversible. Certain things, yes, it is not possible, but at least beyond this damage, we should not do. At least for that, we should have a preparation and other things. So that's what in long term we are working on that. So our objective is basically to translate science to services for the benefit of society.
Okay, that is the vision of Ministry of Earth
Exactly.
Sciences.
So unlike other ministry only do science, no, we want to do services. That is our mandate. That is our primary objective.
Sir, one of the questions which is coming into my mind is ki Ministry of Earth Science often deliver value by preventing losses, then creating visible assets
Correct.
like space or atomic energy. So how do you quantify the impact, like crop saved, life
Yes.
saved?
See, this is what we have to see the economic benefit of this.
Okay.
Suppose recently we have made some independent economic analyst to please quantify our services. Even one cyclone, if you have properly forecasted the life as well as the property saved because of that, it is much more than whatever I invest in compute or observation or the infrastructure, one cyclone, it caters that much economic benefit. So the economic benefit we need to reassess because we are providing potential fishing zone, ocean state forecast, weather forecast. Weather forecast is utilized by renewable energy and farmers and also public and you name it, any industry, weather forecast is important. So we have to cater what is the economic benefit.
Right, exactly.
So we are also maybe we are time and time we are doing maybe a decade ago we have found only for weather forecast and potential fishing forecast what is the benefit. It is roughly about 37,000 crore per year. Only that service. But there are many other services also.
So even if we can prevent natural hazards and these kind of things.
And each hazard, suppose cyclone, tsunami, and marine heat wave.
They take nation 5-6 years back easily.
The Tsunami Warning Center of India is world class.
Okay.
It is one of the best in the world. And if you are able to go to Hyderabad, in case if you see that, one of the modern facilities, you cannot imagine, oh, wow, that wow factor will be there. I think each institutions, as well as our services, we need to be a wow factor so that it can deliver the services to the society.
So I would love to visit someday to have an on-ground shoot.
Yes,
So I was just looking at those stations and I was like, wow.
So this is one of the best stations in Antarctica.
Antarctica. Bharati station.
Bharati station, and where we can live 100 people there at any point of time.
And indigenously built completely by us.
It is India.
Okay.
Of course, the design and other thing is important one.
Okay.
This is basically it is around 150 containers have been merged together.
Containers.
Because the Antarctica, what happened, you cannot spend a lot of time.
I've only seen some things like this in movies only.
Which is very innovative ideas and other thing. And this is pre-fabricated here and has been taken because you have time only 2 months. In 2 months you have to fabricate.
Okay.
Because rest of the month it is complete ice, you cannot work. And you cannot go and come. Okay, so you 2-3 months only you have to do everything. Now this is a summer, southern summer. So we have to do quickly. But we have Maitri station. That Maitri station very soon we are going to rebuild because it is very old. Now we are also planning to rebuild.
Okay. And sir, now we'll talk about Antarctica later on. But talking about Ministry of Earth Sciences and its major missions, so I found 3 on the website.
Correct.
One is Prithvi mission, one is Deep Ocean mission, and one is Mission Mausam.
Correct.
So firstly, we'll talk about Deep Ocean mission.
Correct.
And one simple request is to keep things simple for the layman understanding.
Exactly, that is our problem. But try to you ask me. That's better
Right.
because it is without knowledge. We used to tell scientific jargon, that is why we are telling we fail to communicate.
So you are doing great. I am understanding few things.
But you can, if you have, whenever you come across, please tell us so that I will try to explain that.
So, firstly, talking about Deep Ocean Mission and Samudrayaan. So, it has a huge budget. I think 4,000 crore plus commitment.
Correct.
So, at a time of many issues and going on in the country, monsoon uncertainty and rest of the things. So, what is the strategic and economic importance of this mission? So, firstly, if we can talk about that, then we'll talk about the Matsya 6000. I found that very fascinating mission.
Yeah. So Deep Ocean Mission is basically we have a 6 objectives.
Okay.
Under the Deep Ocean Mission. Number 1 is technology or ocean technology to harness the resources and mitigate the various
resources from the ocean. So kind of mining.
Anything. It is you make it. I was mentioning about resources, about living resources, non-living resources, all.
Right.
Everything together. Energy, water, food, all these resources, even pharmaceuticals, drugs from the sea, all the resources, how do we do? For that, what are the technology required?
Right.
So vertical one is technology. Then number two, vertical two we call, there we were thinking about climate services. That means next decade or next few decades or next century, how Indian coastline will change due to various disasters or hazards like a tsunami or cyclone, sea level rise, all these things, marine heat wave, all these things because of the impact, how our coastline will change. Then we have to say town planning we are doing, like that marine coastal planning we have to do. Where we need to build infrastructure, where we should not build infrastructure in the coastal region.
Okay.
So basically we want to project how our coastal will inundate if sea level is rise like this.
Right. If you talk about Mumbai, Chennai.
Exactly. See, coastal cities, everything.
Right.
So that is the vertical 2. Vertical 3 is what are the biodiversity exists in the tropics. So one way I'm telling weather is difficult to predict in the tropics, but other way is the tropics contains very innovative species, biodiversity is huge.
Right. Particularly in India, there is a huge biodiversity.
So, but we don't have a documentation. So we want to have what are the biodiversity, flora, fauna is available in the Indian Ocean, especially in our EEZ. That is number 3. Number 4 is non-living resources outside India, what is available, like polymetallic nodule or hydrothermal vents, all these things where it is available, minerals and metals from the ocean. Where it is available, how to harness. That is 4th one. 5th one is energy and fresh water, how do we harness from the ocean. And 6th one is ocean biology, or we call as a blue biotechnology.
Right.
How do we do for what is called various pharmaceuticals and especially it is a bioeconomy. When you are talking about bioeconomy, without blue economy, you cannot go bioeconomy. Whatever resources are available in the land, the bio is not sufficient to have bioeconomy. So blue is a main ingredient, seaweed, seagrass. These are the main ingredients for bioeconomy.
We need marine biologists for that, or
of course, all the marine biologists is very important. So these are the 6 vertical. So under the 6 vertical, one of the vertical is, as I mentioned, that technology. Under the technology, there are 2 important things. One is technology for Samudrayaan. Okay?
Right. Samudrayaan.
The Samudrayaan mission is 2 aspects. One is 3 human beings will go up to 6,000 meter dive.
Okay, so this is going to happen.
Yes.
So, we have listened many times about space missions.
It is almost ready. That is the next institution. Please, you visit NIOT.
Okay.
It is a very silently it is going on. So we are opposite direction.
How we are going to send like the kind of pressure and the
that
things
is the way we have to
that
go.
are there.
Opposite direction of Gaganyaan. You know Gaganyaan.
Yeah, right.
So opposite of Gaganyaan is nothing but
Matsya 6,000.
6,000.
Okay.
Wherein 3 human beings will be in this what is called sphere. Will be sitting and they will be going up to 6,000 meters.
6,000 meter.
Yes, 600 bars. So now for that, what are the technologies required and what are the inner sphere, how the human life support system has to be there, oxygen, breathing, carbon dioxide scrubbing, all these things we need to work on. The buoyancy has to be built in such a way, how to go up and down, that one. Not only up and down, we have to go everywhere, side,
Right.
How do we do that? Almost this has been developed. Now it has been developed for 500 meter depth.
Okay.
Except one component is pending, which once that component comes, it is a buoyancy. That is a chain that we are importing from outside. We have designed and fabricated in France, and it will be tested in Norway. After testing, it will come back to India. Then we will fit it and go.
So other than that, this is a completely indigenous mission.
Completely indigenous.
Okay.
And because underwater thing, most of the people they don't share.
Right.
Collaboration will not come in this aspect. See, something we have imported, some small component, but it has been fabricated here. And most of the things are done at India. Even the spear, we want to have a titanium spear. for 6,000 meters.
Titanium sphere.
Sphere.
Okay.
And it is a thickness about 8 to 10 centimeter thickness.
8 to 10 centimeter thick.
Thick titanium
So
sphere.
the body of the sphere. Okay.
Which we cannot develop. We don't have capacity. Only few countries have done. We asked the few countries, they have denied.
Okay.
So we have to develop ourselves. Then our ISRO has come forward. So now they are making this sphere.
Okay.
Once they make it, then we will go to 6,000. But up to now, with this what is called steel sphere, we will go up to 500.
And so navigation systems and rest of the
Everything,
things.
navigation. How do you talk to them?
Okay.
From the ship, you have to talk to that sphere.
Hmm.
How do we talk? You don't have a telephone. You have to do acoustic telephone.
Okay.
So everything.
सर ये कैसे होता है?
Everything has been done.
Okay.
You see, that is about, even though 3 human beings we have to take, that entire things are 25 ton.
So,
Okay. So it is a technology. Of course, the acoustic, what is called underwater technology is unique. So how do we withstand the pressure? That's the main thing. So space, if you go less density, but here if you go high density.
Right.
Fluid is,
So it is hard to go deep ocean, मतलब more than space.
yes.
Okay.
Space, many countries has gone, not below the ocean.
Right.
That's the thing. So, but we have to go because we need to understand the many things. And we have
Sir,
to
I think
explore-
we have explored space a bit, but talking about oceans, I think 95, 96% of the
Exactly,
oceans
that's right.
are unexplored.
See, space, how many people are working? More
Many.
than 10,000. Ocean, how many? And we have so much on the ocean.
So in my whole life, for the first time, I have heard that we are sending humans 6,000 meter deep in the ocean.
Yeah,
I
it
haven't heard it before.
Yeah, it is. See, now recently we went for a technology demonstration also. Our people want piloting. We call, you are known this space.
Right.
Similarly, we call as a astronaut in the space, aquanaut in this ocean.
Equanet, okay.
Aquanaut. So 3 of the aquanaut, our people have gone to France and dived up to 5 kilometers and come back. Because they don't know, suddenly you cannot go here.
So for the training.
Training.
Okay.
And we have made a simulator in NIOT Chennai. If you go and sit there, you are in this pier, sitting there. How to go down, how to go up, and
Wow.
how to pick up the material. Because all the arms and everything is outside this pier. Okay, so you want to take a sample means, how do we take a sample?
So
all these things
I
are
am just
simulated.
imagining the scale of the mission.
Yeah, it is very innovative. And please, if you have time, please visit NIOT and definitely.
100%,
It
sir.
is almost ready, everything. So very soon we will be.
So first we are sending 500 meter.
Yes.
So like talking about the timeline of the mission. So
Yes.
when can we expect that 6,000 meter dive?
Basically, as I told that once the titanium sphere is ready, we will go for 6,000. Next year, 2026, we will go for 500. 27, we will go for 6,000. Already sphere is made half. Remaining half has to be made. That's it.
Okay.
Titanic sphere.
Okay. And so talking about the sustainability part, like when you go inside the ocean, you have to take care of many things.
Yes.
So how we are going to keep this sustainable biodiversity protection and rest of the things?
So whatever we are telling, this is what when we are talking about blue economy, there are
Yeah,
two
right.
components. One is ocean economy.
Hmm.
That is resources to harness. And blue economy means ocean economy plus sustainability. That
Okay.
is what blue economy.
Okay.
So for sustainability, how do you have a mangrove, coral reef, and seagrass? How do you do
Okay.
ecosystem? And how do you sustain the ecosystem to have? And fisheries resources are available. That resources also you have to use sustainably. How do we do that? For that, we need to have a better understanding. So that too, it is a part of this mission.
Okay. And so continuing to blue economy,
Yeah.
so other than fisheries and rest of the things, talking particularly about technology and finding new domains.
Yes.
So what are the next 2-3 domains in tech or startups you are seeing which can emerge largely for the economy?
See, the blue economy, one of the subset is Deep Ocean Mission pilot.
Okay.
Deep Ocean Mission is a pilot project of blue economy for our ministry.
Okay.
But blue economy is not only our ministry. It is a shipping ministry, fisheries, Ministry of Environment and Forest, ports and harbour,
Right.
and also what is called renewable energy, Ministry of Tourism, coastal tourism, how do we do it, coastal heritage, geoheritage,
Right.
and so there are various ministries has to work together. Each ministry is having a pilot project now, like Coastal Mission by Environment, and maybe Sagarmala for Ocean Harbour, and fisheries also many things now. Offshore fishing policy also is released. There are many things are there. All ministry has to work together for blue economy. I think we are working on how do we synergize all the ministry, inter-ministry. Then we need to talk to academia also. We need to have industry. So that is what it is growing now. Very soon it will be coming the policy. Once policy comes out, then we will be happy.
Yes, sir. I think that is the alignment we are looking forward to for Viksit Bharat.
Yes. Actually, future I am sure that ocean, without ocean you cannot have Viksit Bharat. That is my
Right. So even I was looking into many of the things like which are happening in oceans. So first you mentioned about that fish light mission. Then I was also looking like I think Israel have that wave energy farm. So they have some kind of floating
Yeah.
things in the ocean which create electricity too.
Correct, correct. First start with the wave. We can produce wave energy. You talk about temperature gradient. Surface is having 30 degree, 28 degree, 10 degree. If you go about a kilometer, it will be 8 degree. So the 20 degree difference in temperature, we can produce the electricity. Water.
Okay.
Ocean thermal energy conversion. Similarly, if you have a salinity also gradient, wherever the fresh water goes from the sea, like a river meets the sea. River is a fresh water,
Right.
sea is a salt water.
Right.
This gradient also you can produce electricity.
Okay.
Okay. Similarly, why we cannot put a solar panel in the ocean? Why we have to put a land? We can produce put in solar panel.
Right.
Nowadays, wave riding solar panels have come, floating solar panel has come. We can produce energy. And also we can produce a tidal current wave, tidal wave. So there are various forms of energies available. How do we harness? Only thing is, how do you harness economically?
Economically.
Now technology is available.
Everything is available.
Everything technology is available. Only thing is economically it is not viable as of now. See, 10 years back, who knows the solar panel, now it revolution like.
So people are talking about in
Yes.
creating stations in space.
Exactly. So definitely, as I told you, this ocean energy is the next domain we have to harness. So that definitely we need to develop various forms of technology for that.
Okay, great. So now we will talk about Mission Mausam.
Yes.
So it focuses on I think improving weather forecasting and early warning system. So first of all, it has improved a lot significantly in the last 1 decade. So now talking about the ground execution, how it changed life of a farmer, coastal communities, and disaster management. So firstly, if we can talk about that, and then we'll talk about the use of technology in Mission Mausam.
Correct. So first we in the mission Mausam, as you mentioned about our prime objective is to improve the weather forecast.
Right.
The improve the weather forecast means first and foremost how much observation you have,
Okay.
that much you can improve. Okay. Suppose you have an election, the exit polls are there.
Right.
Exit poll, how many exit poll you take a sample?
Depend on sample size.
Exactly.
Rest of
The
the
weather
things.
forecast also, how many places you have a samples, accordingly improvement of weather forecast will be there. As of now, we have very coarse resolution. That means every 25 kilometer, one observation. It is
Okay.
not enough. Every village or taluk, panchayat, we should have observation. If that is the case, we will have a better predictability. So towards meeting that, now we are trying in the improving the observations. So now in 1 year time, we are going to put entire country will be radar network.
Okay.
Suppose last year it was about 30 radars. Now already we have reached about 60 radars. Now we will be having in 1 year, it will be hundreds of radar. So that entire country, all the weather is monitored, that observation will be assimilated into model. So, and also we have satellite observations. So what I want to say, observation will be increased. Then once the observation is there, then the model alone it won't be sufficient. We are doing numerical model, but that alone is not sufficient because numerical model, physics-based numerical model, lot of assumptions we have. Now we need to cater that, we have to go for AIM. So basically we should have a model where fusion of physics model,
Okay.
numerical, and fusion and AI
ML models.
model. Both we need to fuse them. So we are working towards that now, so that we will be able to do better predictability of this one. So observation and model, and also some of the things we don't have understanding. So we want to understand the cloud processes. For
Okay.
that, we are trying to make a cloud chart.
So what is this cloud process? And
Cloud process means how, suppose you have a cloud formed.
okay.
Now, when it will rain,
Hmm.
so why it is raining?
Okay.
Why not it is not? Why it is raining? Why not it is raining? Still, we have a lot of approximation. Basically, when the aerosol particle is there, the moisture will accumulate. Then once after some weight, it will fall. But it is not falling. Why it is not falling?
I think when I was in college at IIT Kanpur, I think we experimented some artificial rain there. So that is also
Yes.
okay.
So the artificial rain also part of this. See, artificial rain also, how do you do? You should have a cloud. It is about to mature. Then you seed it. It is not falling because there is no enough seed to condense.
Okay.
Coagulation, they will call coagulation. But basically, how do you condense that water? Some seed particle is required,
Right.
so that above that water molecule will form. Then it will be bigger size. Then the gravity will bring the water. That's the idea. But when that will be forming, how it will grow, all this process, still we have lack of knowledge.
So once we have better radars, better monitoring,
Yes.
and better idea of things, cloud processing, so we can have a better idea. We can save many
Better
crops.
models. Better
Okay.
models, so that we can have a better prediction.
Then we can save many crops. We can do artificial rains and rest of the things are
everything.
possible.
So once you understand, then definitely it is not only artificial rain making, artificial suppression also important.
Okay.
Yeah, somewhere if it is a flooding, you have to stop. So you have to do that suppression. Or somebody hails are forming, it is
Right.
damaging something. How do we suppress? So all these things we are working on. As of now, 1 year only Mission Mausam started. We are more worked on observation aspect, and parallelly we are working in modeling aspect. So now we need to go for more and more. Finally, our dream is to make weather intervention, improvement of weather forecast, and we should, why not, we should not have a ChatGPT or
Okay.
like that Mausam GPT.
Wow.
That's what we are. So everybody's in hand should be there.
Yes, sir, that's very
Now
cool
if
idea.
I go there, when I have to go, whether I have to take umbrella, or suppose if I am going from Chennai to Hyderabad, no, you have to be told, hey, Hyderabad is going to rain, have you taken umbrella? It has to tell.
We can plan our trips accordingly.
Exactly. Similarly, tomorrow farmers are going for
Crops,
crop
seeding.
what is called some, suppose pesticides.
Right.
Tomorrow is going to rain, so don't do pesticides today
Right.
because it will wash away. So like that, you have to advise on its own. So that is what we are looking at it.
But talking about from the tech perspective, correct me if I'm wrong.
Yeah.
So global system works on exascale computation, and we are still on petascale.
Yes.
So what are we doing for computation and that
Yeah,
things?
we have roughly about 20 to 25 petaflop.
Okay.
So definitely we have to go for large scale computing.
Yes.
In our mission Mausam
Yes.
next scale, we are going for large scale. So we have compute requirement two kind. One is CPU,
Yes.
another one is GPU.
Okay.
GPU to cater AI/ML, CPU to cater physics-based model.
Okay.
So both we are simultaneously growing. So I think next not plan, in 2026 we have 16th finance cycle. During that cycle we are planning for bigger computer.
Okay.
And we are working with the CDAC and Ministry of MIT, so that we are planning to go for more and more compute power in the coming years.
Okay. And so one of the things which I want to talk about is despite like advanced forecasting and air quality too. So talking about Delhi's pollution.
Yeah.
So if we can talk about that, like from atmospheric perspective, like
Yes.
what are the reasons for Delhi's pollution, or it's just humans or us?
See, the Delhi pollution is unique because of one thing is Delhi is bounded with what is called, it is like a bowl sitting there. Okay.
Ball.
Bowl.
Okay. Right.
So and also it doesn't have a wind at all. So any pollution we create, it is not dispersing out. It is lying with us. So our own pollution, we should not produce pollution from local. Remote is little bit. but local is more. So how do we avoid it? It is a policy and other thing, and technologically it is, as of me, nothing is, because if it is a cloud, then only you can see it.
Right.
There is no cloud, you cannot see it. And similarly, how do we do arrest? Technologically, it's very difficult as of now.
Okay.
Unless otherwise, you should have a policy changes like a vehicle movement and how the pavement and other things to be clean, sucked rather than just to throw from one place to another. So various innovative and also people also should be aware about this.
Right.
So various things is important, unlike technological intervention.
So from a tech perspective, at this point of time, we don't have many tech things to do.
Yes.
So
It is mainly
our responsibility.
policy driven. How do we do vehicle? How do we do something cleaning the road? What is the way to clean? It is to be sucking or throwing one place to another. So various kinds we need to think about and we need to evolve.
So Delhi is a bowl because of mountains around it, or
Yeah. It is a mountains around that, and also we have the winds. Always, if you see the Delhi outside, trees will be like a statue. If last few days back it was the wind was there, the pollution level has gone down.
Right.
Because our pollution has been dispersed outside. Now it is whatever is going up and down. Only way is generate, go little bit of sun rises means it will go up, then sunset means it will come down. There is no way to go out horizontally. That is the main problem.
Okay, and sir, just from a science perspective, so these mountains and this Aravalli range, that is also more important for the system.
Of course.
Okay.
Of course.
If you can talk about that, this is one of the hot topic in the country, and I don't want to go into.
As of now, the geoengineering is very less for the air pollution in Delhi. Okay. But you have to have a policy and other issue rather than your technical. As of now. But some innovative idea may come. Still, we don't have.
Yeah, I think we can do.
Yes.
So now moving on, so we'll talk about Prithvi scheme. So if we can talk about that, like how it is built to get an integrated understanding of Earth system and atmospheres to oceans, land and cryosphere. So how it is changed India's capability.
So in the Prithvi, mainly we are looking at it polar science and geoscience and some portion of ocean science. Ocean science means mainly we are looking at the ocean vehicle, that means research vessels. And polar science means, as I told, we are the only country looking all three poles together.
Okay.
One of the country, one of the few countries to looking at Arctic, Antarctic and
Himalayas, right.
We call three poles.
So strategically, which one is most important for us?
The important per se, if you say that, it is obviously Himalaya.
Okay.
Important because Himalaya is feeding water to 2 billion people all around.
Yeah, right.
Okay, if water shortage is coming, then there will be pressure between the countries, between the states about the water.
Right.
So we should know how much volume of water is available, when it will be depleted, what is it, and moreover here also there are many countries around that are all not cordial countries. So how do we cater? So all these things will come. So Himalaya is strategically more important than. Next, I can say Arctic.
Okay.
Because Arctic is having a lot of resources. When Arctic sea ice melts, then there are a lot of changes will happen in terms of climate change, in terms of weather patterns, in terms of shipping route will change.
Okay.
And there are many other resources also, mining and oil and gas resources are very high in Arctic. So all these things is
so we are monitoring and doing research simultaneously on these three.
Correct.
And sir, why globally Antarctica is so important? And that we talk about Antarctic Treaty, so it prioritizes science over research resource extraction.
Correct.
So if we as India expands its Arctic presence, so how do you balance scientific collaboration and geopolitical competition and these things?
See, unlike other places, in Antarctica is no man's land.
No man's land. Okay.
No man's land. And Antarctica, the currency is science.
Science.
Okay.
Okay.
So you have to do only climate research. There it is like a giant elephant. If elephant is having any damage, the implications are very huge for other regions.
Okay.
So each country is looking at it, what is the change is happening. In Antarctica, average ice thickness about 2 to 3 kilometers thick.
Thickness.
Ice.
Okay.
So it is giant ice. Around that, sea ice and other things also there are around the things. So we are monitoring in terms of climate change, what is happening there. Whether first we started with, is there any clue to monsoon? Suppose today some sudden change in the pressure or temperature. Next season may monsoon I have any problem?
So I think you have linked in one of your interviews Arctic with the monsoon linkage in
Correct.
India.
Yeah, that is one. And Antarctica also.
Okay.
And whether we have any link with the Antarctic and Arctic. The sea ice changes in the Antarctic, how it is influencing the monsoon.
Right.
So we are looking at it scientifically, but the background, it is not only science, geostrategically, okay, how we need to, suppose somebody tomorrow, some other country is coming, this land is belongs to me. What is our action? Geopolitical, we want to do it. So that is why we want to have we are one of the countries, science is the governing for the Antarctic. We should not, some of the country climate area, climate countries. Still it is in the dormant, but still we are looking at it, how the Antarctic should be used as a natural laboratory for science.
Right.
That's our objective, which we are driving. It is one of the geopolitical. Tomorrow, suppose it is banned mining, you should not do any other radioactive or any other, everything is banned. That is to be continued.
Okay.
That is our objective. That's what we are working on.
Okay. And so talking about these research and rest of the things, India need thousands of climate scientists, oceanographers, and extreme weather experts. So talking about the current academic and institutional pipeline, you had many of the institutions as a Secretary Minister of Earth Science. So are we facing any bottleneck, or India can do something to align academic priorities with national interest in this domain?
So two things. One is the number of scientists working in this realm, especially atmosphere, ocean, geoscience, polar science, is very minimum.
Okay.
We need to augment more. And that is number one. And second thing is, we cannot get full manpower, but at the same time, the available resources in academia for the knowledge, the available resource in the industry for the developing and delivering the product and services, we need to harness.
Okay.
So one is collaboration, other one is extra manpower, and these are the two important things apart from more financial resources we need to deploy, so that we need to expand, because we are one of the countries having ocean in our backyard. So we need to do much more than anything. So we need to augment manpower plus the financial resources. It should be more than the present. Then only we will be able to do in a big leap forward, and one of the few countries in the top 5, it has to come.
Okay, and I think, sir, like this will happen with the time.
Yes.
And also I think MOEs also provide extra moral support and funding. So if we can briefly talk about that to create an awareness.
So basically in the deep ocean mission or mission Mausam, Prithvi, we try to provide some of the component to the academia.
Okay.
It is extra research. So now, for example, the deep ocean mission, we have made more than hundreds of projects we have given. Even though it may not deliver, but we want to create the ecosystem of the ocean from Kashmir to Kanyakumari, and this side from east, Bhavnagar to Arunachal Pradesh. All the people, hundreds of universities we have opened up. Suppose somebody is sitting in Arunachal, he is working on ocean robotics. Okay, but otherwise they don't have ocean at all. But still that knowledge is available in robotics and other things. They can work in ocean robotics. So similarly, we are creating more and more universities, and other people are coming in our ocean ecosystem. Even biotechnology, we are converting them, normal biotechnology people, to blue biotechnology.
Okay.
We are converting ocean engineers or engineers to ocean engineers.
Yes, sir. I think that is the need of the time, to ability to learn and adapt to new things.
Correct. So that's what we are trying to, more and more project we are giving, more and more people to work on this field. So that definitely some people will be able to do. And my major strength is the biotechnology. Even one molecule if you find from the ocean, where we are biodiversity rich ocean, okay, definitely we will have more and more molecules for the drugs from this.
Right.
So we are encouraging more universities and more institutions to work on this direction, so that definitely we will be having a better result in the future.
Okay, great, sir. On the ending note, I would like to give one message for entrepreneurs, investors,
Yes.
policymakers, or students who are looking forward to pursuing a career in this domain. About why do they care about earth sciences or understanding of the planet, and how it directly going to affect our future and prosperity, security.
So earth science is very unique.
Okay.
Because this science requires all branches of science and engineering.
Okay.
You have a civil engineer, or you have a biology, you have physics, chemistry, or mechanical, electrical engineering, anybody that can work here because they can contribute. So that we can have a earth science in meteorology or oceanography or solid earth, earthquake prediction and other things, and also polar science. We need people. I think but unfortunately we don't have earth science in the basic degree.
Okay.
So because of that, many people are not aware. Suppose if you do physics, people know that from the beginning. Biology, from the beginning knows. Earth science comes laterally. So that's why people are not aware of it, but there are a lot of opportunities.
So, and like you talked about degree, so like material science,
Yes.
physics,
Yes.
or biotechnology. So
Yes.
these all can, like funneled into
Yes.
earth science.
Yeah, that's what. But they have to funnel into earth science. That means all opportunities are available. But we need to have, because many people doesn't know the opportunity
Right.
available. And now it is, I think that is one of the reason this earth science ministry has formed.
Okay.
No other country have a earth science ministry.
Okay.
So India has. So that means we need to justify similar to ocean. Only India is having Indian Ocean.
Right.
Sorry, Indian Ocean is having named after India.
Right.
Similarly, only India has a earth science ministry. We need to do justice. For that, I think we need to work more people, more opportunities are available. I think we can work together. Then definitely it will grow this field also.
Okay, great. Thank you so much, sir. Thank you so much for giving us your time, learnings, and insights.
Yeah.
I enjoyed it a lot, and it is one of the best conversations I've ever had. Thank you so much.
Thank you very much, and I'm sure that this message will take it to more wider
Right.
people, especially students, entrepreneurs, and the academia and industries, so that we can work together for the better service of.
And Viksit Bharat.
Yes.
Thank you so much,
Thank
sir.
you.